Today we're to take a look at transforming quadratics. So last day we looked at the equation y is equal to ax squared plus k, and we talked about vertical shifts up and down, and we talked about changing the shape of the parabola. Today we're going to talk about transformations, or basically moving, or how do you go about moving a parabola either left or right of the y-axis. So to start off, though, we're going to do some warm-up. We're going to describe the transformations to a parent form of a parabola, and then we're going to graph those transformations. So bear in mind, again, that the parent form of a parabola is y is equal to x squared. In this case, we have a parabola that is not in the parent form. Okay, so there's a different value of a and there's different value of k. So first we're going to describe in English what those transformations are. So quickly, let's identify what the a values are and what the k value is. So our a value is actually positive 0.5, and our k value is positive 3. So because the a value is positive, that tells us that it opens up. So it opens up. We also know that because the a value is 0.5, that's between 0 and 1, it's compressed. Okay, so that the shape of the parabola is actually compressed. So it's compressed 0.5. And because we know that the k value is positive 3, it's shifted up 3 units. So it's shifted up 3 units. Okay, so now that we've described it, the next thing that we need to do is actually graph it. Okay, and we talked about the step pattern last time. And again, quickly to rehash the step pattern for a basic parabola is the over and up. Okay, so the over is the x coordinate, and then the up is the y coordinate. So let's just do a basic 1, 2, 3 over and up situation, and we know that a step pattern goes over 1, up 1, over 2, up 4, over 3, up 9. Okay, and so this part represents y is equal to x squared. Okay, and again, y is equal to x squared is the parent form of a parabola that has not been changed in any way, shape, or form. Okay, and using the step pattern chart, we can actually figure out, well, what is the new value of y? Okay, and so because we know that the a value is not positive 1, we need to actually adjust the shape of this parabola. Because it's 0.5, we know that it's compressed. It's still shifted or still opening up, but it is definitely compressed. And so what we need to do is we actually need to figure out, well, what's the new y value? So we're going to call that y2. Okay, and in order to figure out the y2 value, you take your y1 value and you multiply it by the a value. Okay, so y2 is equal to y1 times the a value. Okay, and so we're going to do 1 times 0.5, and that equals 0.5. Y2 is 4 times 0.5 is equal to 2. And here we've got 3 times 0.5 is equal to 4.5. Okay, so our new step pattern is over 1, up 0.5. Then over 2, up 2. Over 3, up 4.5. Okay, we could continue going on and on and on. Okay, and so if we go about graphing this, what we end up having, if we graph the original, okay, we'll graph y is equal to x squared. So over 2 up 4, over 3 up 9. Okay, so this is our original parent form of the parabola. Okay, so y is equal to x squared. But now what we're going to do is we're actually going to graph the parabola that we've been shown. Okay, so we know that the parabola has been shifted down by 3 units. So the original parent form of the parabola had its vertex at 0, 0. The parabola y is equal to 0.5x squared plus 3 has its vertex at 0 plus 3. Okay, so uh, its vertex has been shifted up 3 units from the origin. Okay, and now what we're going to do is we're going to use our step pattern. Okay, we're going to go our new step pattern. So the over 1 up 0.5. So this part of the step pattern. Okay, so we're going to go over 1 unit, but instead of going up a full unit, we're just going to go up half a unit. Okay, and then we're going to go over 2 units, up 2 units, again from the vertex. So over 2 units, up 2 units. Over 3 units from the vertex and up 4.5 units. So 1, 2, 3, 4. Okay, and so our new parabola is actually a little bit fatter. Okay, so it doesn't come up nearly as quite as steeply, but it in fact comes up just a little bit narrower, or sorry, a little bit wider than it does before. Okay, so now that we've done some review, we're going to take a look at expanding our knowledge of the quadratic equation.